The welding joints. In this video, we're going to discuss the welded joints, the type of joints, the welding symbol terminology used in communicating the specifications on engineering drawing. Then we'll discuss how to calculate the stresses on weld and the welded joint and the strength of the weld and the parent material. A weld. It is defined as a zone of metal that joins the two or more components created by localized melting, mixing and the cooling of the metal from the parent component and an expandable filler metal of compatible composition. Melting is accomplished by using the heat source such as an electric arc or oxyacetylene flame. There are various types of welding procedure that we are knowing here. The spot welding, then we have TIG welding, MIG welding, projection welding. So we have given here two metal plate and we wish to make a joint. For this purpose, these two plates are first clean and then the welding is done on this corner as well as this corner. So this is a welding is done in this fashion. Depending upon the force required, we have to do the welding. So we are interested here what is the size of the leg. This one is called as leg, which is represented by H. This one is also leg size equal to H, and we have L is the length of weld. Whatever the force we applied to the plate, the weld must be able to withstand the given force. That is, the stresses developed in the weld zone must be less than the allowable stresses. A joint. A configuration of a parent component defining a gap to be filled by the weld metal, and weldment, a structural component constructed by welding several components together, is called as weldment. This type of weld is called as the fillet weld. Even though we can do the fillet welding from the bottom side also, so this one is a cross section, which one is triangular cross section, and we have a welding here. So it's the same idea again whatever we done on the top side. This particularly joint refers here the T type of joint and is a fillet type. Second type we have a butt type, and there are the various types of butt joint also that we'll discuss later on. Various types of welding process are available. We can have arc welding, uses a welding power supply to create an electric arc between an electrode and the base material to melt the metals at the welding point. In the case of electric arc welding, we are using both, that is a consumable electrode or non-consumable electrode. Say for example, we have shield metal arc welding where we are using the consumable electrode. Even the gas metal arc welding, we are using a consumable electrode. Whereas in the gas tungsten TIG, that is the gas tungsten arc welding, we are using a non-consumable type of electrodes. We are not interested in the process of welding, rather we are interested in the design of the weld joints. We are already familiar with the riveted joint, bolted joint. Similar to that we have welded joints. So welded joints are the other type of permanent joints which are widely used apart from the riveted joints. This type of welded joints are basically simple as compared to the process involved in the riveting. Since the welded joint does not require any other material, and in the case of riveted you have to use the external rivet, so riveted joint will be heavier as compared to the welded joint. So there are the certain advantages of a welded joint. It is comparatively lighter than the riveted structure. It has a greater strength compared to the riveted joints. Addition and alterations can be done easily, and we have a better finish than the riveted joint, because after you do the riveting, then you can do the grinding and we can meet the finishing surfaces. Its maintenance cost and the painting cost are also less. It required less time as compared to the riveting joint. The tension members are not weakened in the welded joint compared to the riveted joint, because in the case of riveted joint we are making the holes, and because of that one the member will be weakened because of a less area. That is not true in the case of welded joint. As such, we are not making any type of hole in the case of welded. The fatigue strength of the welded joint is also more as compared to the riveted joints. But a riveted joint is much simple and non-skilled worker can also do the riveted joint. Whereas in the case of the welded joint, which one is a basically disadvantage in the case of welded joint, it requires a skilled labor because it is to maintain a distance between the weld and the welding torch. So therefore we require a skilled labor. Possibility of the additional stresses, that is called as residual stresses, development due to the uneven heating and the cooling, or in the other words, because when we do the welding, the parent material will also get heated, so it is not a localized heat. In some welding procedure we have a localized heat, but in the case of arc welding, which is normally 50% of the industrial use, we have heat is transferred to the parent material, and therefore additional stresses will be developed due to uneven heating and the cooling. So that is the formation of residual stresses. And sometimes because of the heating, the member may get distorted. Secondly, the grain structure is also affected, and there is no provision for expansion or contraction of joints. Cracks may develop and propagate. So these are the 4 disadvantages of the welding joint. Now once you do the welding, then you have to communicate the welding to the welder. For that one, you have to first study what are the different type of welding joints we are using, what are the different symbols are used, and how to communicate your welding to the welder. If you have to join the 2 parallel plates, in that case you have to do the lap welding. And if you have to join the 2 metal plates edge to edge, then it will be called as butt welding. If the thickness of the plate is large, in that case you have to use the arc welding, and if the thickness of the plate is small, then you can use the spot welding. In the case of a spot welding, we have 2 plates, electric current is passed, and because of the resistance between the interface of the 2 plates, a localized heat is developed. Once this heat is developed and the fusion is start, then we will form here a nugget. Once this nugget is formed, then the force is applied externally to get a spot weld. As such, in the case of arc welding, we do not require any type of force, only the fusion process is required. So here we are doing the welding, that one is called as fillet weld. So this one is called as fillet weld. The shape is basically triangular in shape. A cross section is triangular. Edge is called as the leg size. This time we are doing the T joint, and we have a fillet shown as here. We have plate 1 and plate 2. They are welded. Is also a type of fillet weld. But when you have to do the butt welding, and depending upon the thickness, we have to use here the square, V, bevel, U or J type of butt welding. In that case, you have to make the groove similar to the shape of a square, V, bevel, U or J, and then the welding is done. So if you want to make a V groove weld, in that case first you have to make the groove of triangular in shape. In that case, the weld is formed in this shape. This shape is similar to V, hence it is called as the V groove weld. In the V groove weld, we have thickness of the plate is T1, and if this thickness is increases, that is the value of T2 is greater than T1, then you can make here double V type of groove weld. So double V type of groove weld is used when the thickness is higher as compared to the thickness in the V groove weld. Sometimes we are using the U groove. In that case, we will get the weld type in the form of U. Here we are getting the weld groove in the form of V. And the last type is J type of groove weld. So somewhat J shape is used in the groove weld. Sometimes we require to weld a hole or slot. In that case, the weld is done along this corner. This one is called as the plug weld, or is called as slot weld. So welding is done inside the slot, hence it is called as slot weld. This one is also representing the fillet weld and is a T form, but the base plate is not at the bottom. So here also we have to use the fillet weld. So this one is representing the fillet weld cross section, and this weld you have to do up to the length equal to L. Same fillet weld we can do from the bottom also. So this one is also example of fillet weld. When you want to communicate it here to the welder, what type of joint we have to use, whether we have to use a lap joint or butt joint, out of butt joint, whether we are doing the groove, double V groove, U groove, J groove, or we are using the spot welding and the plug and slot welding. So symbols are used to denote here each type of welding. As far as the fillet weld is considered, it is represented by using a symbol using a triangle. If it is on the top side as well as bottom side, then you have to show the 2 triangles, one on the top and one on the bottom. So where your arrow represent, that will be your fillet welding. So triangle symbol is used for fillet weld. For double V groove and the V groove, we are using a symbol in which you have to show the V on the dotted line, and if it is double groove, then you have to show one more V on the bottom side. The symbols are very straightforward. Whatever the cross section you visualize, that is the same symbol is used for fillet. If you are visualizing V here, then the V is shown on the weld line. Then if you have a U type, then the U is shown. So this one is representing the single U. Similarly, if you are using a double U, in that case you have to show the U on the bottom side also. And for J groove weld, you have to show the symbol as J. Not exactly J, but similar to J. In the case of a plug or a spot weld, you have to show the plug symbol using a rectangle. And in the case of the spot welding, you have to show it as a shape of a nugget. Normally the shape of a nugget is a vertical one, so you have to show the circle on the dotted line which indicate a spot weld. So say straightforward here, we have a triangular, then it's a fillet weld. If it is a V type, then it's a butt type welding, and we have to make a V groove weld. Then we have double V, then you have to show double V. Then we have a U groove, then we have a J groove, and in the case of a slot, you have to make the slots on the top and bottom. That is, you have to show the rectangular section on the top and bottom. And spot welding, you have to show the circle on top and bottom. So these are the symbols that you can communicate to the welder, whether you are doing the lap welding, or fillet welding, or any type of this groove welding. So these are the figures where you will find the different configuration of the parent component. In this case, both the plates are welded side by side. In that case, we have butt weld. If it is overlap, it is called as lap joint. If the welding is done for the two plate at the bottom, it will be called as the corner weld. Then if you are forming a T here, then it is called as T weld, and the edges, when we are making the welding on this corner, then it is called as edge weld. So whatever the welding you are doing here, you have to represent by a arrow of welding symbols. And since we are doing here the butt welding, so you have to show the symbol for butt welding. So if you show this symbol in a butt welding like V shape, so this side, that is the top side, represent here the arrow side of joint, and this bottom side represent here the other side of a joint. So this arrow represent here the welding symbol. You are shown here the V type, and this arrow head you are showing on the top side. So that one is representing the joint where we are doing, and the other side, if you want to show on the upper side, then that will be the other side of the joint. This time it is representing the arrow of the welding symbol. Suppose we are making here stitch weld, that is the welding is done at here at this point. Then the symbol represented as a stitch. So this one is the same symbol that is used for stitch. Since we are joining here two plate, plate 1 and plate 2, the bottom plate represent here the welding is to be done on that side. So arrow side member of the part, that is the plate number 2, that you have to represent on the bottom side. So no symbol is used on the top side, that will represent the other side of the member joint. In the corner weld, we are using the lap weld, and that is from this side, that is this edge. So this one is the edge on the arrow side member joint, and this one is the edge which one is other side of the member of a joint. Since we are using here lap joint, you have to represent this by a triangle. So this one is symbol used in the case of corner joint. So this welding you have to carry out from this edge, that is called as arrow side of joint, whereas this edge which is flush with the top plate is the other side of the joint. And since no welding is done on this side, no symbol is used on the top side. In the case of T weld, you have to do the lap joint here. If you do the lap joint here on this side, so this side is normally represented on the bottom side. So this one is representing the lap joint. And this side also we are doing the lap welding. So this side will be represented as the other side. Other side you have to always show on the top of the arrow. So this represents here that we have the lap weld on both sides. Finally, we have a edge weld where on this edge we are doing the welding. So that is represented by a symbol using two parallel lines. So these are the notations that you have to use. Be careful about the arrow head. Arrowhead is always pointing where you are doing the welding. If you are doing the welding on this side, then you have to show the symbol below it. On other side, you have to show it on the top side. Like in this case, if you are doing the welding on this edge, it is shown on the bottom side. On the other side, you have to show it on the top of the arrow. So we are introduced here some symbols for lap, fillet, butt welded, corner joints, how to represent it with the help of arrow. Here we are discussing the weld specification according to AWS, which stands for American Welding Society. So the weld specification consists of the parameters like the type of weld, size of the strength, root opening and the throat, and the depth in the case of plug weld. Then we have which type of welding process is used, number of the spot welded, the length of the weld and the pitch in the case of stitch welding. Stitch welding is same as that we are doing in the case of shirts. Then we have finishing and groove. So all this space above and below is used to represent the parameter in the case of weld specification. For figure I have shown here one fillet weld. Actually it is not always a fillet weld, any type of weld we have. This horizontal line here indicate the reference line. Using this weld specification, we can communicate the engineering drawing to define the parameter of the weld for fabrication purpose. So some space is reserved at the tail, that is represented as T here with the symbol T. This T represent here the specification, processes or other reference. So what are the different type of welding process are used is represented by T or specification. In the case we do not want to use any reference, then the tail can be omitted. So it is not compulsory right here. If you want to specify what type of process, then you have to represent here the arrow and you have to show here what type of welding process we are using. Above and below you have to represent here the basic weld symbols and detail reference. That is in the case of lap joint, you have to show on this arrow a lap. If it is the V, then you have to show the V. Likewise, the symbols are used on the top and bottom. On the bottom side, you have to use the arrow side symbol, and the top you have to represent the symbol on the other side. So this is what we have discussed here, the how to represent the symbol on the arrow side if it is a lap joint. If it is the corner joint, you have to use this symbol. If it is a weld on both sides, you have to use this type of symbol, that is a triangle up and down on both sides. If it is a butt joint, then you have to show the symbol of a root opening, throat and depth in the case of plug weld. So this one is same place, you have to use the symbol equal to R. R means here we have a root opening or throat and the depth. In the case of the stitch type of welding, we have to use the length of the weld and the pitch. So that time you have to use the length as L, pitch is equal to P. So what is the length and what is the pitch? So that space is shown somewhere here is L and the length is L and the pitch is equal to P. So L represents here the length of the weld and P represents here the pitch, which one is center to center spacing of the weld. If we find a circle here, it means that we have a weld all around the symbol. In the case of resistance welding, you have to show the size or the strength of the resistance weld, that is represented by S, and this space you have to use here on the top of the reference line. And how many number of spot weld we want to do, that is represented by N. That number you have to write down at the bottom of the reference line. The information about the finishing, which is represented by F, and the groove is A, that you have to write down on the top side of a reference line. So F represent here finishing and A represent here the groove. So this one is called as the weld specifications. So the space above the reference level, that is the other side and the arrow side or both side. So different types of symbols are used. That is the groove weld symbols are used as a square, V, bevel, U, J, that I already introduced to you. Is almost same symbol that we use to form the shape, that is a V shape, bevel shape, U shape, J shape, square shape. Fillet is very commonly used the shape as a symbol of a triangle, plug or a slot or the spot or projection. So this space you have to utilize on the top and bottom to show the correct symbol, what type of weld we are using, whether we are using the groove weld or fillet, plug or the spot or projection welding. Now consider we have a fillet weld on both the side here, and this fillet weld size is having a leg size equal to h. So this one is representing the leg size equal to h. Let's say we have a leg size equal to 6 mm. So you have to write down the dimension as equal to 6, and the arrow side represent here this weld, which one is a lap weld. So you have to use the symbol as fillet weld symbol. This symbol is same as this fillet weld symbol. Whereas your the fillet weld on the other side also, which one is also lap, so that one is represented then again by, so this one is representing here the other side. I hope that now the meaning is clear, other side and the arrow side. Now both sides here we have a equal size of a leg, so it is written as 6 mm. See, 6 mm is leg size. Consider the second figure here, in which we have a circular pipe and we want to weld this on the one plate. So the weld is done on the circumferential area. So that is represented by the lap weld here. Since here the welding is done around the whole circumference, so you have to show the circle. Assume here the leg size again equal to 6. So I will write here 6, and this side represent the fillet weld. So we have to use the symbol for fillet. This doesn't mean that we are on the top side, that is the other side. Actually it is a welding is done around the circumference of a pipe, and therefore you have to show a circle, that is a weld is around. So this one is the case of a circular fillet. Now consider the situation here, we have a two large plate and which are making a T-joint. So welding is done on the both sides of the plate. So this time the stitch is used here. So in this case you have to mention the length of the weld L and the pitch P. Suppose we have a length L is equal to 50 mm and we have a pitch is equal to 150 mm. Pitch is measured from this point to this point. Since here we have a fillet weld on both sides, so we have to use this symbol, which one is a fillet weld. So first show the fillet weld on the arrow side. So I will represent here because I don't have a space available here. So let's represent here the fillet weld symbol, and since here we have a alternate type of fillet weld on both sides, so you have to show the fillet weld slightly away from the first fillet weld symbol because we have a length and pitch. So this time you have to mention the length as well as the pitch. So length you have to mention as 50 and pitch you have to mention as 150. This one is representing the length and 150 is representing the pitch. Now using this you are able to read the drawing now. Now consider here the three types of T-joints, and we have the different value of the stitch weld. All these cases we are using here fillet weld, so symbol is represented as same as a triangle. Suppose we have to weld here on this side. This one is representing the weld on the arrow side. Suppose this length is equal to 75, and the other side we have again the fillet weld, and this length is totally equal to 125. Sometimes you have to do the stitch welding. So stitch welding can be done like this. We have one stitch here and we have second stitch here. We can have even number of stitch on other side also, that is not visible on this side, or we can have three number of stitches on this side. So when you are using a stitches, in that case you have to show the length of the weld as well as what is the spacing between them. So 3 stitches on this side and we have 2 stitches on this side. So I will show here just for your interest. So in all these cases you have to represent the length L and what is the pitch. So this time we have length of weld is equal to 75 and we have a fillet type of weld. So that information you have to show on the bottom side with a symbol equal to the fillet weld, and we have length is equal to 25. This weld is on the other side, so other side you have to always represent on the top of the arrow. Again we have a fillet weld, so you have symbol equal to fillet weld and the length is equal to 125. So this additional information you have to show if it is a unsymmetric type of weld. This one is the second type of T weld. We have 2 stitches on the right side and 2 stitches on the left side. Again it's a case of fillet weld, so you have to show the fillet weld on this side. So this side is a arrow side, so you have to represent by a symbol using fillet. At the same time you have to represent here what is the length and what is the pitch. So length we can say is equal to 20 mm and the pitch is equal to 100. That information you have to provide. On the other side also we have two stitches and is a fillet again, so you have to show the symbol of fillet. And since we have two stitches and they are symmetric, so you have to again write down here the length of the weld and we have pitch is equal to 100. So L stands for length, P stands for pitch. Now this one is again a stitch joint but unsymmetric. If it is a unsymmetric, then don't show the symbol of each other, rather they have to offset here. On bottom side you have to show the symbol of fillet. You have to show the size of the weld, that equal to 20, and we have pitch is equal to 100. On other side we have only two pitches, so you have to make it offset and you have to show the symbol of fillet, and we have same length weld equal to 20 and pitch is equal to 100. So this one is a little idea about weld specification and what type of symbols to use and how to write down the details about the length, pitch. In the case of the square, V, bevel, U type or J type of groove weld or fillet plug. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.